And quantum theory predicts bounded linear finite states. So the two don't agree. And so since then we have this thing, and so we have this chasm between the two. Einstein tried to put it together, but he couldn't. And, you know, the problem is that when you look out there, big things are made out of small things. So obviously, those physics must match. Right? Well, the chasm is much deeper than that. The chasm between the understanding of infinity and bounded state shows up in our society everywhere. I'll give you an example. Spiritual people tend everywhere. I'll give you an example. Spiritual people tend to think in terms of infinity, that like this infinite potential, you know, that all things have infinity within them and all this. And the scientific community tends to think in bounded, closed systems of finite, you know, rational concepts. And so the two don't agree, typically. The chasm even goes deeper. I think the deepest of that chasm is the difference between female and male. Women typically think in terms of continuum, in terms of curvature to infinity, like infinite possibility. Everything is okay, honey, right? And man thinks, in general, have a tendency to think in bounded state, you know, finite, highly logical systems. And the two can, in some cases, not agree. Statistics on divorce can support that statement, right? And so, but how do you solve it? I mean, there must be a solution, because men and women are here, because scientists and spiritual people are here, because large things are made out of small things. How do you connect infinities and finite systems? And I started to think about it at that age. By the age of 11, I was kind of despondent because, you know, I wasn't fitting in so well in society, and so I was not so happy, and I was actually pretty well ready to exit stage left, you know. And I met, luckily, a master of meditation that was not much older than me. I think he was like 15 or 16. And he taught me how to meditate. And when he taught me how to meditate, I learned that you can turn your senses from the outside to the inside, and you can go towards the center, and you know, there's a whole world there. And as I thought about that, I thought, maybe the solution between infinities and finite system is that there's stuff going in and then there's stuff going out, and the two, you know, meet and create boundary conditions that we think are finite boundaries. And so I start to extrapolate on that, and later on I realized that there is a simple geometric solution to the riddle. So in a simple geometric solution here, I'm going to prove to you that infinities and finite system are absolutely related. Actually, one cannot exist without the other. And so we'll make a boundary. We'll call it a finite boundary. This is a circle. And it encloses a certain volume, right? It could be a sphere in the space. So don't reduce it necessarily to a circle. And then inside it, we're going to put an equilateral triangle. Now, that triangle in a sphere could be a tetrahedron. Everybody knows what a tetrahedron is? It's one of these, right? And we can polarize that tetrahedron because the universe has spin. Things spins in the universe, and when they spin, there's polarity. So it's okay, you can polarize it. So you can polarize the triangle. And interestingly, right away, you got an ancient symbol that you can find in many, many different cultures all around the world, although it's best known by the Jewish culture as the Star of David or the Star of Zion. Well, if you look carefully, you find that as soon as I polarized the first tetrahedron, I created new boundaries that have the exact same geometry that I started with. Except these boundaries are one step smaller, right? They're one gradient or one iteration smaller. Well, what's important to remember here that each of these boundaries define a very specific center, right? Like this boundary here, this is its center and this is its center. And all of the centers are all different from all other centers. That means that each of the boundary, although they are part of a similar geometry that is interactive with each other, meaning one cannot exist without the other ones, they all have their own very specific coordinates in space-time, and they observe the rest of the fractal structure from its own very specific point of view that no other boundary in the system has. You all following this? It's an important point. Now, you can polarize those, and you'll get smaller boundaries again. And again, each one is a very individual boundary. And you polarize those, you get smaller ones, and you can go to infinity doing that. So if I had this program running on my computer, it could keep zooming in and making more boundary and zooming in and making more boundaries, and it would go to infinity. Like, as long as the computer was running, it would keep going. However, I would never, ever, ever, ever escape or exceed the first boundary I've made for myself. So within the context of a finite space, I've embedded infinite amount of information. Infinite amount of divisions. That means that if this is true, and if it's geometrically true, and if it's mathematically true, then it most likely is true, you could take the boundary of any of your atoms, or the boundary of your cells, and divide them and divide them and divide it to infinity, meaning that you have an infinite amount of information, an infinite amount of divisions within yourself. So all of a sudden, you're starting to have a mechanical and mathematical understanding of the infinite nature of your existence. It's no longer just a metaphysical concept. It's no longer a belief or a dogma. It's actually a mathematical equation. Does that make sense to you? So this is crucial, because without it, you're still in dogma. And so, what does it mean to physics? I mean, it means a lot to spirituality and philosophy. But what it means to physics is that if physicists understood that, this simple example, they would stop building accelerators. We keep thinking that we're going to find the smallest particle. Not so long ago, a few centuries ago, we discovered the cells, right? And we thought, oh my God, cells are so small. They must be the smallest thing the universe does. And then we realized cells were made of billions of atoms, and atoms are so small. We thought, oh my God, that's got to be the smallest thing the universe does. The God particle. And then we found, oh, the God particle is made of smaller particles, protons, neutrons. And we went, oh, and they're like bitty little things in a very small thing to start with. And it was like, oh, that's got to be the God particle. And then we found subatomic particles and so on and so on. And it's like, wait, And every time we're finding these new particles because we're building larger and larger accelerators so that we can accelerate particles at faster and faster rate and collide them together to get smaller and smaller and smaller particle. And now we've built a device that's like an accelerator that's 17-mile long. I think it's cost like $10 billion at this point or something. It's extreme. It took like 5 countries to finance it. And we're thinking we're going to find this final particle, and it's like, and guarantee you there's some smart person out there that's going to find a new way to write the equation and go, oh, maybe there's something smaller. We need to build a larger accelerator. Well, those things have a finite limit, meaning like there's constraints on what we can build. So maybe instead of looking for a fundamental particle, a God particle, we should start looking for a fundamental pattern of division. Because if we understood the pattern, then we would understand how the universe creates. We would have the key to the divisions of the space that produce our reality. We would have the key to creation. That could be fairly useful. And so I started to think about that, and I was like, wait, let's ask a fundamental question. If you were asked to point at something in the universe that connects all things, what would you point at? What would it be? If you had all the universe, everything you see, and I asked you, find me something that connects all things, because you hear that a lot in the spiritual world, and from masters that in ancient times and so on, that everything's one, right? But how? If you don't tell me how, then it's just a concept. It's just a dogma. You got to tell me, how is that possible that everything's connected? Like, you got to explain that to me.
Consciousness.
Well, if you say consciousness, you haven't explained anything, because probably every person in this room has a different definition of consciousness. So, what would it be? Space. Very good. Very good. Space is everywhere. It's between galaxies, it's between universes most likely. It's between stars, it's between planets. And at the atomic level, the space is extremely high. Atomic structure, all of your reality is built out of 99.9999999% space. So everything you say is so solid, is so real, that you think of as your reality is actually mostly space. And it's oscillating, and the oscillations interact, and did you know that you actually haven't touched anything at any time, anywhere? Nothing